Alright, so for number 1, we have to put it in standard form, so we go from the highest degree to the lowest degree. So this one, 9x to the 5th, and then the next one would be negative 3x to the 4th, and then plus 5x cubed, oops, that's a cube, minus 10x squared, plus 2x minus 1. Identify the leading coefficient. So the leading coefficient is the coefficient of the leading term. So in this case it's 9. So 9. So leading coefficient is 9. The degree, that's the degree of the polynomial, so it's the highest degree, so it's 5. So the degree is 5. And the number of terms, well, the number of terms, you just count 1, 2, 3, 4, 5, 6. So 6 terms. Okay, for 2 through 4, we're going to add or subtract, so, and write answer in standard form. So what I do is just look for the highest degree in both polynomials. The highest degree is 3. So I'm going to combine, and because this is addition, we're just going to combine. So keep the signs the same. So 7x cubed minus x cubed, that gives you 6x cubed. Then you look to see if there's any square, and in this case there's just one x squared. Then you look to see if there's any x, and there is let's see, 1x right there and 1x right there. So 2 plus 2, that's 4. And then you look for a constant. Alright, and finally, the constant, we have -1 and -6, so that's going to be -7. Okay, number 3, we're subtracting, so before we go on, let's change all the signs. So I'm going to, okay, let's see, change the signs here. So this is going to be a -4, a -8, a +4, a -2, and a +1. Okay, so the pink signs are the signs that we're going to be using for each term, because this negative right here, the subtraction, changes the signs of everything after it. Okay, so now the highest degree here is 5, so I'll start with that. So I've got -5x to the 5th, and I've got +4x to the 5th, right? Because I'm looking at the pink sign now. So that leaves me -x to the 5th. Then I look to see if there's any fourth powers. There's only one, and it has the pink sign is negative, so it's -4x to the 4th. Then I look for any cubes, and it's a 2x cubed. That's the only one, and it has a pink, a negative pink. Then I look for any squares, and there are none. I look for any x's, and I have 2 of them. So I've got -8x and -11x, so that's going to give you -19x. And then constants, I've got 12 plus 1, so that's 13. For number 4, same thing, I'm going to change the sign, so this is going to be a plus, this is a minus, this is a plus, this is a plus, and this is a minus. And again, that's because we're subtracting, because of this negative right here. So the highest degree here is 6. So I'm going to start off by writing, and there's only one of them right here. So I'm going to write x to the 6th. Then I look at the 5th power. So I'm just going down 1 degree at a time. So -9x to the 5th plus 2x to the 5th gives you -7x to the 5th. And then 4th powers, I have -3x to the 4th and +x to the 4th, because I'm looking at the pink sign over here. The pink sign, so that's going to give me -2x to the 4th. Cubes, there are none. Squares, there are 2. a 2x squared, and a 4x squared. So that gives me a 6x squared. X's, there's only one right here, negative x on the right one. And then constants, I've got negative 7 and negative 12, so that gives me negative 19. For number 5, we're going to use distributive power, or distributive property. So where this gets multiplied here, here, and here. So you end up with negative 10 x squared y to the third. Usually we put the variables in alphabetical order. That's why I put the x squared first. And then negative 4x y to the fourth. And then positive y to the fifth. And that's it. Number 6, you can do a little 2 by 3. I'll put it here on the side. See if it fits. I know I didn't give myself a lot of room, but so 2m squared and n, and then 3n squared, 6mn, and negative m squared. So I'm going to multiply. So that little dot means multiply. So this is 6m squared n squared, then 12 m cubed n, then negative 2 m to the fourth. Then I'm going to multiply the n's, right? So 3, oops, it doesn't look like a 3 n to the third, 6 mn squared, and negative 2 m, sorry, I'm looking at the wrong one. For the last one, I kind of messed up for this one. And then that's going to be negative m squared n. Okay? And there are no like terms, so you just write it out. 6m squared n squared plus 12m cubed n minus 2m to the fourth plus 3n cubed plus 6m n squared minus m squared n. So no like terms. Okay, number 7. This one I might be able to fit a little bit better. So this is 2x squared minus 1, and this is 3x squared minus 5x and positive 2. So this is 6x to the fourth minus 10x to the third, 4x squared, and then negative 3x squared, positive 5x, and minus 2. So the only like terms here are the 4x squared and the negative 3x squared. Okay, everything else is just there one time. So let's go write it in standard form. So 6x to the fourth minus 10x cubed. 4x squared minus 3x squared is x squared. 5x minus 2, and that's the answer. So we do the same. Alright, so this one's going to be 8x to the sixth, 4x to the fourth, negative 4x, negative 10x to the fifth, negative 5x cubed, plus 5. So we're going to take, there's no like terms, so we're just going to get all the terms in standard form. So the highest degree is 6, so it's 8x to the sixth, then 5 to the fifth, then the fourth degree, then the third. There is no square, minus 4x plus 5. For number 9, I'm just going to use distributive property, so I'm going to multiply this times this, and this times this, and then this times this, and this times this. Okay? Notice this is one term. Okay? It's not two separate terms. So a cubed times b to the fourth So a, where is it? A to the third, b to the fourth, and then a cubed times a squared is a to the fifth. And then I move on to the next term, a squared b squared times b to the fourth is going to be a squared b to the sixth. And then a squared b squared times a squared is going to be a to the fourth b squared. Alright, so k to the fourth times k squared is k to the sixth. K to the fourth times negative k is negative k to the fifth. Negative 9 times k to the fourth is negative 9k to the fourth. Then k cubed times k squared is k to the fifth. K to the third, that gives you negative k to the fourth. Then negative 9k cubed. Then 12k squared minus 12k minus 108. Okay, combining like terms, well, I've got negative k to the fifth and positive k to the fifth. That actually cancels out. Okay, and then I've got negative 9k to the fourth and negative k to the fourth. So this does not cancel out, so that one's going to stay. So we're going to write the answer k to the sixth. The fifth is gone, minus 10k to the fourth, then minus 9k to the third, plus 12k minus, squared, sorry I forgot the square, minus 12k minus 108. So that would be the final answer right here. So on number 11, we can factor out a 3. So that's the first thing I'm going to do is factor out a 3. That leaves me with 4v to the fourth minus 25. And what I have left in parentheses right here is the difference of squares. So that's going to equal 3, and then 2v squared plus 5 times 2v squared minus 5. For number 12, if there's a GCF of 5, I can factor out a 5, so I've got p to the sixth minus, what is it, 16. So this is also difference of squares. So this is a difference of squares because that's an even power right there. So it's 5, half of 6 is 3, so p cubed plus 4, and p cubed minus 4. And that's as far as you can go. Number 13 is difference of squares again. So this would be 4c squared minus 9d squared and 4c squared plus 9d squared. Now I could factor this further because this is still difference of squares. Not the second one, but this one I underlined, I could factor some more. So that would be 2c plus 3d times 2c minus 3d, and then I'm just going to bring down this factor right here, 4c squared plus 9d squared. So this is a complete factorization of number 13. Number 14, there is no GCF, but I noticed that this is a perfect square right here, and this is a perfect square. So I'm going to check and see. This is 2x to the third, and this is 8y to the third. When I multiply 2 and 8, I get 16. When I double it, I get 32, and that's exactly what you have right here. Okay, so the factored form of this one, this is a perfect square trinomial. You put a square up there and you're done. Okay, number 15 has a 5y squared as a GCF, so I take it out. And so I'm left with x squared minus 25. And this is a difference of squares, so you get 5y squared, and then x plus 5 times x minus 5. And that's it. Number 16, I have